we are going to continue discussing different types of operating systems or different features of operating system. The first type of operating system I'm going to talk about is the multi-user operating system. Let us say we have a single computer, and to that single computer we have a number of users who are connected to that computer. The users are generally connected to such a computer via a dumb terminal. A dumb terminal is just having a keyboard and monitor. So on a single computer, just a single copy of the operating system is running, which allows all the users to work on the same processor and operating system parallelly. The advantage of a multiple or a multi-user operating system is it ensures that all the costly hardware devices are used effectively and efficiently. Now, when users connect to this computer through networking technology or terminals which are networked, there are various challenges to be handled. Such a multi-user operating system, for example, should see that I do not read your data. You should not read my data from the memory. I should not go and delete your code in the memory. So all these challenges are handled by memory protection. Also, it is possible that I may be wanting to write five five files at the same time. You may be also wanting to read from those five files at the same time. Obviously, there is going to be a problem because as I am writing, things will change. As you're reading, you will get changing data. To ensure that all these problems go away, it manages concurrency of resources so that a single resource is used by at the most one process or user at a given instant of time. Now, since it supports the usage of the hardware resources by multiple users, it is therefore known as a multi-user operating system. Now, when you have a multi-user operating system, the different aspects which need to be taken into account is it should keep track of who is using which resources, how much time he or she spent using the resources, authenticating them in the sense trying to see whether that user is a valid user who is supposed to or allowed to use the machine. Okay. Now there may be hundreds of resources, a few selected printers, for example, may be allowed or allotted only to a specific group of users. So all that restrictions are managed by this multi-user operating system. And as I earlier said, you may have your own private files, private data. It should ensure security of that data and code and see that people who do not have permission do not access that. So these are all the challenges which have to be handled by a multi-user operating system, and these are also the challenges which are handled by them and the features which are provided by multi-user operating system. Now let's try to understand what is a real-time operating system. Let us say I am driving a car. The minute I see some animal come in, I apply the brake. But let us say to my bad luck, I go and hit the animal, or let's say I hit the side of the road. Now, when I hit the side of the road, the modern cars have airbags which open up in front of my face to protect injuries to me. So, such a job of opening the airbag after an impact is done by something called as a real-time operating system. What a real-time operating system does is it responds to real-time events within a dedicated instant. So the minute I press the brake and I hit something, when it hits something, it gets certain vibrations. It should detect the vibrations, and before my face goes and hits the front steering, the balloon should open up so I am protected in the front. So here it should respond to that event, accident event, very fast within microsecond. It cannot say, chalo, I'm going to respond to you after 2 seconds. By that time, my face will be smashed. So here, utilization of resources and user friendliness is not that important. The response to any event is most important. If it is not able to respond to an event in a fixed amount of time, that operating system is supposed to have failed in its operation. Now, such things are used in industrial control processes, like I gave you example in cars and industrial flight control. Say, for example, I have automatic computers installed in my industry. When there is smoke, straight away the water sprinklers should start around in no time. It cannot detect the smoke and wait for minutes together to release the water. So this is an example of a control process in industries which use embedded systems. Or I can give you another example. Suppose you have fitted a camera on your house. If it detects some strange movements, it should immediately raise an alarm. Such a thing is known as a, or such a device uses a real-time operating system. Real-time operating system are used in a lot of embedded systems like a washing machine, microwaves, cars, and so on. Examples of RTOS or real-time operating systems are Windows CE, Linux, and RT Linux. Now, let's talk about time sharing operating system. Let us say I am again connected to a computer. Okay, or let us say 50 or 100 users are connected to a simple central computer. Think of an example of a railway reservation. When you go to a railway reservation counter, the master servers are located maybe in Delhi and Mumbai. Here the users just have a simple terminal and a keyboard. They are trying to book ticket for you. So that is a job which requires interaction with the screen. Okay. So what, when you're booking a ticket, there is one or many CPUs. There are hundreds of users who are trying to book ticket, but it divides the CPU time between all the users so fast, or it switches between all the users so fast that each user will get the feeling that as though he or she is being attended solely. So time sharing operating systems are used where interactivity is important to users. Like suppose we are booking railway tickets, the clerk is also booking take tickets. So for all of us, that server or that main machine should respond very fast in no time. So a time sharing operating system exists there which allocates the resources of the computer in very micro time slots to different users, and they all get the feeling that they are being attended to or taken care of solely. Time sharing systems are used widely where there is heavy interactivity between the user and the computer. Now, time sharing also includes facilities for doing multi-programming. A time sharing system, you can run more than one process at the time. You can do multitasking and so on. Important feature of a time sharing operating system is since users are sitting in front of the PC or computer, it is required to provide extremely fast response to users' needs. It cannot wait for minutes together and then respond. Generally, the way of responding is if there are 50 users, it will give 1/50th of a second for each user and it will keep switching between them. This is known as round robin, or sometimes it may determine some users have more priority, so it may give more time. So giving little amount of time to each user to do his or her job is known as time slicing. And time slicing algorithms implement time sharing operating system where each user is given a fraction of the time where he or she gets the feeling that he or she is being solely attended to. Although it is switching between different processes so fast, but since it switches so fast, you get the feeling that you are being taken care of solely. Time sharing is implemented in most of the modern operating systems like Linux, Unix, Windows 2000 Server, and so on. Applications of time sharing operating system, your railway reservation, computer aided design, or if your multiple people are processing the web on the web or using the web at the same time, the text processing is done by multiple users. Again, it uses the operating system used here is a time sharing operating system.